Today we're going to look at 4-5, day 1. All right, so what I want you to do is take your paper and divide it into 4 quadrants, the whole page. All right, in this top page, in this top left quadrant, we're going to do definitions. In the quadrant next to it, we are going to do simplify radicals. In the lower left hand, we're going to do rationalize. In the last quadrant, we're going to do conjugates. Okay, so we're going to start with the definitions. So in the definition quadrant, and I'm doing this so that you guys can see, so I don't have to squeeze everything in there, but please write this all in that quadrant. We're going to first write down the product property. The product property says the square root of a times b is equal to the square root of a times the square root of b. So an example would be the square root of 36 is equal to the square root of 6 times the square root of 6. Whenever you take the square root of a number times the square root of the exact same number, you just get that number. And the next thing we're going to write down is the quotient property. And these are all properties that you've seen before. We cover these in Algebra 1. We also cover them in geometry. So the quotient property says whenever you have the square root of a over b, that's the same thing of the square root of a divided by the square root of b. So basically you can break up the radical. So an example would be if you had the square root of 49 over 25 all in the radical, you could separate that to the square root of 49 over the square root of 25, which would then be 7 over 5. And then finally, the last thing that we're going to do is we'll go ahead and write what the definition of conjugate is. And the definition of conjugate says that if you have a plus the square root of b, its conjugate is a minus the square root of b. So basically, when you multiply the conjugate, if you were going to FOIL these two, the two middle terms would be left, would cancel out, and you'd actually be left with a squared minus b. And I'll show you how that works in a little bit, but that's what a conjugate is. So notice that the a stayed the same, the square root of b stayed the same. The only thing that changed was the sign in between. First it was a plus, second it was a minus. Okay, so that takes care of our definition quadrant. So now we're going to move to the simplify radical quadrant. And you've seen this before. We stress this in both Algebra 1 and geometry, but let's go ahead and cover it again. Let's look at the square root of 80, and I'll show you how I do this. Might be a little bit different than you've seen before. I use the prime factor trees to help us. I'm not a big fan of memorizing all infinite number of perfect squares. So we'll break it down and think about what prime number goes into 80. And I always use 2, something easy like that. And then it goes in 40 times, 2 goes into 40 20 times, 2 goes into 20 10 times, and 2 goes into 10 5 times. So then this index number on a square root actually has an index number of 2. So what I do is I picture these things like they're going to a party. So whenever you have a pair, which is what you need because the index number is 2, you circle them. So we say that the 2s have a friend, and then they ride together in the car to the party together. So there's those 2s going in the car to the party, and then there's these 2s going to the party in the car. And then this sad little 5, he doesn't have any friends, so he has to stay in the house. Right? And so if you have more than one like this guy does, you get to multiply what's outside, and then the 5 stays inside. So you can check your work. If you were going to take the square root of 80, you'll get a decimal, and that will be exactly the same decimal as 4 times the square root of 5. So that's one way to check your work. All right, let's look at another one. Let's look at what happens if we have the square root of 6 times the square root of 21. Sometimes there's a little multiplication problem first. So what you do, it's best to multiply those together to get 126, and then we always need to simplify our radicals. So obviously 6 and 21 go in there. Break down the 6, break down the 21, circle your pairs. So the 3s are going to the party, they're riding in the same car. the 2 is sad, the 7's sad, so they're staying in the house, and that makes 14. All right, so we'll look at that some more tomorrow. All right, for the next quadrant, let's look at rationalize. We also do this in both Algebra 1 and geometry. So hopefully this looks a little bit familiar. So let's say that we have the square root of 5 halves. So using the quotient property, we'll go ahead and make that the square root of 5 over the square root of 2. All right, it's illegal to have the square root in the denominator, so we need to rationalize to get that guy out of there. So we're going to multiply by the square root of 2 over the square root of 2. So basically what I did was I made a big fancy 1 out of whatever was on the denominator. Okay, then we just multiply straight across. So really I have the square root of 5 times the square root of 2 over the square root of 2 times the square root of 2. All right? So that makes, using that product property, that makes the square root of 10. And remember, whenever you multiply the square root of a number times the square root of the exact same number, you get that plain number. Now, square root of 10 and 2 can't reduce. They have different values. So square root of 10 is not 2. So they don't simplify to make a 1. So one guy is in the house, one guy is out of the house, so they don't match. All right, you can only reduce guys that are in the house with other guys that are in the house, or you can only reduce numbers that are outside of the house with other numbers that are outside of the house. Okay, so you can't mix numbers. All right, the last section we're going to look at is conjugates. This part's brand new. We do it a little bit in Algebra 1, but it's at the very end of a section. So let's look at, first off, let's just go ahead and talk about what conjugates are. So let's say we have 7 plus the square root of 2. What would the conjugate of 7 plus the square root of 2 be? So its conjugate is 7 minus the square root of 2. So first guys are the same, and the last guys are the same. The only thing that changes is the sign. All right, so let's look at 8 minus the square root of 3. Its conjugate would be 8 plus the square root of 3. So we use conjugates to simplify radicals. For example, if we have 3 over 7 plus square root of 7, I have to rationalize, but I can't rationalize with just the square root of 2. And I'll show you why tomorrow in class. So we have to use its conjugate. So 7 minus the square root of 2 over 7 minus the square root of 2. So on top we have to distribute. So I get 21. And then the 3 is an outside number and the 2 is an inside number. They cannot mix. So we have 3 square roots of 2. Because really you can only take outside numbers times outside numbers, so we have that invisible one that's in front, implied 1. On the bottom we're going to FOIL. So we're going to take first, outside, inside, and last. Notice that these middle terms cancel out. So I have 21 minus 3 square roots of 2 over 47. And that's how you use conjugates.